Okay, now let us see how we handle this case now. We are going to handle now string. Now this is going to be our next example. So I'm going to ask that one end of an elastic string of natural length 4 meters and moduli 730 newtons is fixed at one end at a point A, and the body of mass 500 grams is held at the other end, resting on a smooth surface, causing the string to extend by 20 centimeters, so that when the body is released, it will move with simple harmonic. So from there, I see that they are giving me the natural length. So in my solution, I'm having natural length. L is going to be 4 meters. What else? I'm having modulus of elasticity as 72 newtons. What else? I also have the mass. The mass they are giving me 500 grams, which are going to be equal to 0.5 kilograms. As simple as that. And then this one was smooth surface, etc. So they are giving me also the extension. The extension is going to be 20 centimeters, which is the same as 0.2 meters. So this is the extension, but we don't know the displacement. So we say let x be the displacement. Displacement after release. So now, to illustrate that, I'm going to be having this as, so I have my string, this is my string, it's fixed at one end A, and the other end we have, so this is the string I'm having, then I'm having the body of now, the weight is now 0.5 kilograms. And now, of course, our expression is there. Now from here, we are going to say, let it be displaced x centimeters there. That's going to be our displacement there. Now, of course, we are going to be having attention in a string in that order. Then we are going to be having from there up somewhere, we are going to have the natural length. Then we shall be having the extension of that string there, and then it's the displacement caused by that t there. So from there now, we resolve. If we try to resolve in that direction, we all know that there is no force pulling it in that direction. So we have 0 n minus the tension equaling to ma. Using Newton's second law of motion, that's our, let me state it first, so that we can see what happens. So, if you resolve horizontally, it means that now, using Newton's second law of motion, the resultant force is always equal to mass minus the acceleration. So you see the force pulling it in that direction is 0, you don't have any other force, because even the surface is smooth. So you have 0. Then minus our tension equaling to the mass, which is 0.5 times the acceleration. Now, because this one is now describing a simple harmonic, it means that now our acceleration is going to be x now prime, because we are assuming that x is the displacement positive. So we have here negative t equaling to 0.5x bar. And then you know from Hooke's law, that the tension in a string is given by lambda, the extension over the displacement over L. So from there, I'm going to be having now minus 9 negative. See from here, I have my t equaling to lambda. My lambda is what? Is 72. 72 times the displacement x over the length, which is 4. And from here, that 90 is going to give me 72 divided by 4. I'm getting 18 newtons. Then if I substitute in here, I'll be having this as negative, I have negative 18x. This is x, this is the newtons, but we have x here. Okay, so putting in here, I have now my 18x equaling 0.5x double prime. And so now my x double prime is going to be negative 18 over 0.5x. Okay, so after that, I'm going to be having now my x prime double prime as that is negative 36x, and you see, so this is our part A, which is in the form x double prime equaling to negative omega squared x. And you say, the moment if they want to show that the forces acting on the body and described in the simple harmonic, and then show that all those forces we reduce to an equation, we express it in that form as you can see there. So that means that now show that when the body is released, it will move with simple harmonic. Hence the body will move with simple harmonic motion with its. So part B, they're telling us that find the amplitude of the motion if the particle's maximum velocity is 45. They're giving us that RV max is going to be 45, whereas RV max is given by the amplitude. Now, this is how I define my amplitude with R times omega. So we need omega to get this. We have this, we need this to get this. So from x double prime equals negative 36x, if I compare with x double prime equals negative omega squared x, negative, so that now there my omega is 36. So if now my omega is going to be 6 rad per second. So now if I substitute there, if I substitute now from my V max, our R, that will be equal to our V max. So I need my amplitude into 6 equaling to 45. So my R is going to be equaling to 45 divided by 6, which is 7.5 meters. So that's the amplitude of that particle if they're giving us the maximum. This is maximum, that's why I'm able to use this. If they just tell you velocity, then you use this squared equal to omega squared into R squared minus the displacement C squared. So that's it, members. I wish you well.